Hello everybody, this is Jyoti Mayekar and this is first lecture on nanotechnology. So Richard Feynman said when we will have some control of the arrangement of things on a molecular scale, we will get an enormously greater range of possible properties that substances can have. And this is very true for nanoscience and nanotechnology. So what is nanoscience? Nanoscience is the science of objects with dimensions on the nanometer scale. Nanometer scale in the sense one of the dimension it will be less than 100 nanometers. This size regime is controlled by what is called as quantum mechanical effects, or most notable the quantum size effect. This scientific field is in the interaction zone of physics, chemistry, biology, material science. So you can say that nanoscience basically it is interdisciplinary science. So, what is nanotechnology then? Nanotechnology thus refers to techniques that offer the ability to design, synthesize, or manufacture and control at the length scale below 50 or 100 nanometers. Now, here I have emphasized the words design and control because in the last decade, much work is done in the field of synthesis, but there is much room for the development to design and control. Now, what are the key properties of materials and devices that deal with nanotechnology? So, first property is at least one dimension. It should be of about 1 to 100 nanometer, and it should be designed through process that exhibit fundamental control over the physical and chemical attributes of molecular scale structures. Third, it can be combined to form larger structures. Now, basic component of nanotechnology, it is nanoparticles. So we will talk about nanoparticles. So a 4th century Roman masterpiece, that is Lycurgus cup. So that exhibits the unusual property of dichronism. So here you can see this cup. They are not two different cups, that is a single cup, but here you can see that the color is different. In one case you can see some red orange color, in the second this one here it is looking green in color. So same cup, but you can see the different color. Why there is a change in color? Because of dichronism. What is dichronism? Glass appears to be green in the reflected light, and the same glass appears to be red in the transmitted light because of nanometer particles which are suspended in glass. Okay. Second example of nanoparticle, it is Faraday Gold, and this also date back to Roman times and were known to the medieval alchemist as aurum potabile. The notion that gold souls indeed contain some metallic particles was first expressed by Faraday in 1857. He had conducted a very elegant and simple study of the optical properties of thin films prepared from dried colloidal solutions. He observed reversible color changes of the films upon mechanical compression, and here you can see this is the colloidal solution of gold, and you can see the color is different depending upon the particle size of the gold suspended in that particular solution. Now, how nanoparticles are different from microparticles? So microparticles or microstructures mostly exhibit physical properties which are very similar to that of the bulk counterpart. But in the nanometer size regime, new mesoscopic phenomena characteristic of this intermediate state of materials can appear. Furthermore, the stability of crystal structures can decrease in nanometer sizes. The ferromagnetics can be varied when particles reach the nanometer size. The magnetics can become super paramagnetics when materials shrunk to nanometer scale. The nanometer metal particles can become or lose their catalytic activity, etc. So, all these things happen when the particle size reduces to nano range. Now, why the properties change at the nanoscale? This can be discussed in terms of organization of atoms or molecules into condensed systems, due to which new collective phenomena of materials are developed. Cooperative interaction is responsible for the physical properties of the materials, and it varies with the size of agglomerates in the nanometer scale. Thank you so much.